Sir, shall we begin? It's 10:30.
Please go ahead.
All right. Good morning, everyone. Thank you for joining in today. Today is the third day of the webinar. As you know, MRC has been diligently taking care of all the projects that you've been doing, guiding you and mentoring you. I'll take this opportunity to specially thank Sridhar and Ananya, who started this whole internship program together with you guys. And I also congratulate all of you for putting in all the hard work and culminating the whole process with your report and finally this presentation. So today we have groundwater management in Brahmaputra Basin by Vanishta, advancing water quality in Indus River Basin by Sneha, real-time underwater quality management systems by Chirag, machine learning based estimation of nutrient concentration for rivers by Athar, urban flooding management by Minachi, AUV design for deep sea mining by Arijit, and AUV design for climate change by Pratham. Thank you all for joining in today. As I call in your name, start presenting. All the best. First of all, we have Vanishta presenting her work on groundwater management in Brahmaputra Basin. Vanishta, the stage is all yours.
Thank you, ma'am. Good morning, everyone. I'm Vanshita, an engineering physics undergrad at IIT Guwahati and also an intern with MRC. Today, I'll be presenting my work on groundwater management in India. Moving forward, these are the contents. First up, introduction. So as we all know that groundwater is a vital resource for India. It supports various sectors such as agriculture industry and is also used for domestic purposes. But rapid growth of population and increasing water demands have put in significant pressure on groundwater management. So we need proper groundwater management techniques to stop the depletion, contamination, and long-term consequences on groundwater. Moving forward, the defined problem statement. So this project basically
Vanshita, sorry to interrupt you, but your screen is frozen. So can you put it in slideshow mode properly and start
okay.
it? Share your whole screen.
Okay, ma'am. Now is it visible?
It is.
Okay.
Thank you.
So next up, why I chose machine learning model. So classical model, basically they lack understanding of complex hydrological systems and they require large number of data. But in contrast, machine learning models, they are able to analyze nonlinear data and are able to cope with any kind of data basically. Moving forward, methodology. So first up, data collection and the various pre-processing steps such as screening, feature selection, and normalization. For groundwater quality prediction, I chose a random forest classifier, and for level forecasting, RMA and LSTM were combined. So this was basically an ensemble model. Random forest is ensemble learning method which was successfully able to capture the relationship between features and groundwater quality parameters. And in second case, RMA, the time series analysis technique, it was successfully able to capture the temporal patterns and seasonality in groundwater data. LSTM was able to capture the long-term dependencies in data. Moving forward, the results. So for quality prediction model, random forest classifier model achieved an accuracy of 82%. And for level forecasting model, RMA yielded MAE of 0.5, which indicates a deviation of 0.5 from actual dataset, and RMSE was 0.27, which is relatively low. So these results highlight the accuracy and reliability of developed models. Moving forward, this is the correlation matrix for groundwater quality management, like predicting model, and the confusion matrix for random forest classifier model. Next up, this is plot for groundwater level prediction, which depicts the seasonal components of feature, rainfall, hydrometry, volume, temperature, and depth to groundwater. And this is the final plot, which depicts MAE and RMSE and loss. So talking about implications and applications, the research have implication for improving groundwater management practices in India. This can enable decision making, early detection of water quality issues, and optimal resource allocation. These models can be further included in various government policies and can be used to successfully predict groundwater level and quality in future. Talking about limitations and future directions. So limitations can include data availability and quality, the generalizability of the model to different regions. It can vary, right? And also the few assumptions which were made. And the future directions, such as we can enhance this machine learning model by incorporating some extra additional features such as extraction rates, aquifer properties, climate change projections. That way it will be more accurate. And we can also explore further hybrid models that are available, which can increase the accuracy as well. Collaborating with local stakeholders, government agencies, and water management organizations, they can implement these developed models, and they can be used for actual predictions. Now conclusions. So the project was successfully demonstrate how machine learning models can be used for quality and groundwater level forecasting. And accurate prediction enable proactive decision making and effective resource allocation and groundwater management. And obviously, the effective groundwater management is crucial for ensuring sustainable water resources and safeguarding public health. I have listed the references that I've used here. Yeah, that's it. Thank you.
Thank you, Vanishta. Next, we have Sneha. Sneha Sahu from IIT Delhi.
Good morning, everyone. My name is Sneha Sahu. I am from IIT Delhi. I am interning at MRC. So I was working on the topic of advancing water quality monitoring in the Indus River Basin, exploring technological intervention. Moving on with the introduction part, the significance of the Indus River. It is a vital water course in South Asia, supporting diverse ecosystem, agriculture, and providing water for various purposes. It stretches across Pakistan, India, Afghanistan, and China with primary tributaries including Jhelum, Chenab, Ravi, Rees, and Satluj. It faces challenges including water pollution, degradation of water quality, and adverse effect of the climate change. The division into tributaries present unique challenges in managing water quality, as each tributary carries its own set of pollutants. Then urbanization and industrialization in the basin have intensified water quality challenges and posing threats to human health, biodiversity, and ecosystem integrity. Now, the objective of the report, recognizing the critical and significant use of the Indus River, identifying technological gaps in Indus River and the near water bodies, investigating technological intervention to advance water quality monitoring. Now, the parameters affecting water quality. Water quality in river is crucial aspect of overall cleanliness and health of water environment. It is influenced by various parameters within catchment area. Some of the parameters are temperature, pH, dissolved oxygen, biological oxygen demand, nitrate concentration, conductivity. So the reasons for the changes in these parameters are fertilizer and pesticide because of improper use of fertilizers. Improper use of fertilizers and pesticides can lead to water pollution and can harm aquatic life. Dams and reservoirs. Changes in river flow due to dams can negatively impact aquatic life by reducing oxygen level, altering temperature, and impeding sediment transfer. Then industrial waste product Toxins such as metal, organic molecules, and harmful chemicals can harm aquatic creatures, pose risk to humans if used for drinking or irrigation. Now, the how is water quality monitored in Punjab? So it is monitored by the Punjab Pollution Control Board, in which samples are taken monthly and analyzed at the laboratories. They focus on mainly on the Satluj, Rees, Ghagar, Ravi, and major trails, which is done under the National Water Quality Monitoring Program. Now the technological gaps which are found. One is real-time monitoring issue. As seen in the last slide, the monitoring is done on the monthly basis. So they pose some challenges such as difficulty in identifying pollution source due to mixing with other material contaminants present in the water. Delayed response to pollution incidents resulting in slower identification response. Then insufficient data resolution as short-term variation are not captured. Next is water treatment infrastructure issue. It requires the challenges are capital cost, such as construction of treatment facilities, installation pumps, filters, disinfection system, and system creating network require significant investment. Then operation and administration cost. Water treatment, wastewater treatment is necessary to eliminate pollutants before release or use. Biological treatment using natural microorganisms is energy efficient compared to physical and chemical treatment. Physical and chemical treatment require mechanical equipments and energy intensive processes. Next issue is discharge of untreated and industrial waste. Indian urban industrial waste pollutes the Indus River. Industrial wastewater contains various chemical and pollutants can harm the environment and human health. Untreated industrial effluent in agriculture can affect soil fertility, crop growth, and ecosystem health. Next issue is return of agriculture content to drainage structure to the river. The farm waste that flows into the Indus River through sewage system contributes to water quality, salinity, and pollutants from agriculture effect. Uh, the last issue which I found is certain pollutant not tested, such as pesticide and fertilizer. Lacking of testing of these pollutants poses challenges in assessing and addressing their impact on water quality. Then why the need of continuous monitoring system? Because of water quality assessment required in order to get the real-time data on various parameters, then pollution detection and sources identification, environmental impact assessment, agriculture, aquaculture industry, and warning and mitigation. Some of the technological intervention can be used in order to fill the technological gaps. One is satellite monitoring system. It uses satellite imagery to assess water quality on large scale. It equipped with sensors, capture data and images of water bodies, enabling analysis of various water quality parameters. It relies on spectral analysis, detecting and measuring electromagnetic radiation reflected or emitted by the water surface. The benefit of this system is assessing aquatic ecosystem health, detecting algal bloom, identifying pollution source, supporting water resource management and decision making. It uses algorithm and model to drive quantitative estimate of water quality parameter. Uh, Now the working of satellite water quality monitoring system. The system measures reflectance of light from water surface using satellite sensor. Based on reflected light concentration of substances like chlorophyll, suspended sediments, pollutants are determined. Information are used to create water quality maps for monitoring and identifying areas for further investigation. It establishes long-term standards globally and provide real-time local and global information. Remote sensing system measures the total radiance over water considering atmospheric path radiance. Pre-surface layer reflectance, subsurface volumetric reflectance, and bottom reflectance. Now the sensors and ML model. So satellite-based monitoring system use multispectral, hyperspectral, and synthetic aperture radar sensor. A sensor detects different substances in water, including pollutants, suspended sediment, and changes in surface roughness. Image processing technique applied to satellite data. Then ML model requires in order to analyze satellite imagery data to extract relevant information. Then ML model enable automatic data collection. It stimulates future water quality considering temperature, land use, and past trends. But it has some of the limitations such as spatial resolution, as it can't show very small changes in water quality, which are of the places which are very close together. Spectral resolution, it can find many wavelengths of light, but this might not be precise in order to find certain parameters. Then it must atmospheric condition as due to presence of cloud haze or aerosol, it can the monitoring can be affected. Cost and infrastructure. Initially, it is expensive in order to acquire satellite data and infrastructure. The next intervention is sensor-based water quality monitoring system. It is used. It is used in various part in India. It uses sensors or sensor arrays to evaluate measure various parameters or indicator of water quality. These systems provide real-time or near real-time monitoring of water bodies, enabling continuous data collection and analysis. Specialized sensors are used to detect and measure specific water quality parameters. Sensors are designed to robust, accurate, and sensitive to small changes in water quality. So, sensor-based water quality monitoring systems are widely used in environmental monitoring, water resource management, aquaculture, drinking water treatment, in industrial process, and research studies. So, the working of this sensor, as seen in the images, the main controller is connected to different types of sensors. These sensors are placed in water that needed to be tested. The sensors reading that are converted by an analog to digital converter, and the main controller reads the value, which are then sent to the cloud for storage. The values are continuously measured to see if they exceed a certain limit or not. If a value exceeds the limit, it is communicated to the relevant user so they can take appropriate action. Some of the sensors are PS sensor, DO, dissolved oxygen sensor, biological oxygen demand sensor, conductivity sensor, turbidity sensor, temperature, ORP, TDS. There are many sensors available. But it has some of the limitations such as sensor accuracy, because sensor could be affected by falling, drift, etc. So they need to be calibrated and checked regularly. Spatial coverage, as it is cover only limited part of the area. Then maintenance and structure, it need to be checked regularly. So it requires maintenance. Cost, as it is expensive in order to install or maintain the cost of the sensor. The last one is for water resource management in order to prevent the runoff from the field to the industrial, that is precision irrigation. It is crucial approach to prevent chemical and fertilizers from running off into the water bodies from farms. The benefits are controlled use of pesticide and fertilizer, linking precision watering system to automatic or customized computerized control, ensure accurate delivery, reducing the risk of overspraying or excessive application that can lead to runoff. Then next benefit is variable rate irrigation, as it provides different amount of water and nutrients to a different area of field based on soil type, crop needs, and terrain. It also offers some advantages such as enhanced water use efficiency, ability to use liquid fertilizer, and cost reduction in nutrient application. Implementation considered for precise irrigation requires soil moisture sensor, weather station, efficient irrigation system, water delivery infrastructure, automation, and control system. Some of the challenges are cost consideration for implementing this system, adequate training and capacity for development, ensuring proper maintenance and regular calibration of sensors, addressing potential data management and analysis. So that it has limitations such as affordability and cost, technical expertise and knowledge, infrastructure requirement. Future scope for enhancing future scope in this section is automation and canal operation and groundwater irrigation can improve efficiency through sensor integration. Artificial intelligence techniques such as hyperspectral remote sensing and machine learning can optimize water application parameter and irrigation schedule. It also can assist in optimizing water resource and planning sustainable infrastructure and developing efficient water systems. Thank you.
Thank you so much, Sneha. That was a detailed presentation. I now welcome Ambassador Anup Mugdal and Vice Admiral DSP Verma. They have joined us today for day 3 of the webinar. Thank you so much, sir. And also welcome all the dignitaries and guests who have take out their time to join us today. And I would like to request all the questions that might be coming up to be put into the document that has been shared in the chat box so that we'll deal with them towards the end. Thank you so much. And moving on, we have our next presentation by Chirag Chamankhare, who will be speaking on real-time underwater quality management systems. Chirag.
Good morning, everyone. My name is Chirag Chamankhare. I'm a third year BTech student at IIT Delhi. My branch is mechanical engineering, and I'm a research intern at Maritime Research Centre, Pune. My topic of research is real-time underwater quality management systems. The flow of content goes as follows. First, we'll deal with introduction, then uh, WSN and IoT-based system, then remotely controlled model. Then we'll talk about the disruption networking technology, and then we'll wrap up with acoustic sensing model and conclusion and application. So basically, the 21st century is the century of pollution, global warming, insecurity, and vulnerable health factors. Water pollution is a major problem in front of the world today, which is nothing but the contamination of water bodies. According to World Health Organization, more than 3.5 million people die every year due to water-related diseases. This indicates that water quality is very important in today's world and also with the growing degrading water quality. Now, moving on, we'll talk about the different systems that can be implemented and used to make a real-time water quality monitoring network. First, we'll talk about wireless sensor networks. It uses different sensors and it collects various parameters from water such as temperature, pH, oxygen, density, turbidity, etc. It is basically divided into three main parts, that is data monitoring nodes from which the data is eventually extracted and sent to base station, and from base station it is sent to the remote station. from where it all can be controlled. The data is sent through the Zigbee gateway from sensor nodes to the web server via a WiMAX network. Now we'll talk about the IoT based system. Here, the core controller is capable of processing the measured values from the sensors. The core controller is created using the Arduino model. Here, we can also cover the parameters such as temperature, pH, turbidity, and flow of water. Flow of water. Here, the data transfer takes place over the internet. All the interconnections are done here via Wi-Fi. As you can see, the figure here shows the architecture of the model, and various sensors can be attached to the system also. Now talking about the real world model that can be implemented on water bodies. Here it is shown the architecture of the whole model. This remotely controlled boat can monitor the real-time water characteristics of a water body, and it is a need of the hour. To track the latitudes and longitudinal values, we have connected a GPS module to the RX of Arduino. And movement of the boat is done by a combination of two DC geared motors, which are controlled by the L298 motor driver. Here, due to vast areas that we have to cover, we can make use of Wi-Fi module instead of a Bluetooth module. And with this model, it is convenient to detect water quality of a concerned location from a remote station at real time. Now, talking about the methodology of this model, uh, all the sensors can be placed in this structure made by PVC pipes. The output characteristics obtained can be used to plot a geomap of the respective water bodies and help find possible zones of concentrated contamination. The whole structure works on a based platform uh, named as ThinkSpeak, and the data is transferred through a LoRa sender and received via a LoRa receiver, which is connected to ESP32 gateway via SPI communication. To ensure the boat would float and accommodate the necessary sensors, the buoyant force generated by PVC pipes have to be twice that of the weight of the components. The result of these tests are displayed on the liquid crystal display that is attached to the model itself. Now, talking about disruption networking technology, uh, this will provide network services for environments to extreme and that where no end-to-end path exists through a network. Currently, end-to-end congestion is handled by TCP protocol, but there's a weakness in this technology as it cannot deal with network congestion, whereas disruption networking technology handles in managing network congestion, which is very useful to deal with distant of places that is very difficult to reach. It uses a story carry forward method to resolve the issue of information exchange. Here, each nodes take decisions by its own whether it has to transfer the data to other node or not, based on the limited connectivity. Uh, Due to the consequences of this, no data can be lost in a limited connectivity environment. So that is a very useful technology to be installed in our model. Now talking about the second model, we have acoustic sensing model. It senses the sound signals uh, exported by various ships moving on the water bodies. As it is shown here, it is a real-time marine acoustic signal sensing system. It is also equipped with frequency domain beamformer, GPS, field programmable gate array, carrying the process with a floating buoy. The figure shown here shows here the structure of the whole electronic components. That is, the array is connected to the amplifier, which amplifies the signal, and filter that filters the signal, which is then connected to ADC for analog to digital conversion. And then through FPGA, we receive the measured values of the of the sound signals. Here, a vertical linear array of 2 or 4 RHSA10 hydrophone models attached to the buoy for sound detection. The buoy can be controlled from a remote location. Here we have used a vertical linear array because it is the only feasible solution to be attached to a floating buoy. If we had chosen the uh, uh, if we had chosen the space configuration of hydrophones or the planar configuration of hydrophones, it would be difficult to connect it to a floating buoy and getting the real time measurement of sound signals. Also, the linear configuration of hydrophones is very important because it uh, differs in array directivity of different configurations for receiving of incoming signals. Like if we change the array configuration from 4 to 2, it will highly differ in the measured values of incoming sonar signals. So MATLAB simulation is done here to show the results of various array configurations, that is basically done over two two node system and four node system with gap spacing is different in each system. And for the purpose of simulation, following inputs were taken into consideration. The sampling frequency is taken to be 250 hertz because we are concerned on acoustic measurement of shipping traffic, and the average frequency that is released from the ships is around 100 to 500 hertz. So that's why 250 hertz has been taken as the sampling frequency. Now, the propagation speed that we have taken is 1530 meters per second, which is the speed of sound in water bodies. Also, we are dealing with not a very deep level of water. We are dealing with the shallow depth of water bodies. So, the azimuth angle is not taken to be very large, as can be seen here. It is taken to be 15 degrees. Now, talking about the applications of these systems, these can help in hotspot detection. By measuring the various parameter values, we can come to know that if any parameter value is exceeding the uh, preset limitations or not, and correspondingly work on those particular locations. Also, with the measured values of dissolved oxygen and biological oxygen demand, we can come to know about the health of aquaculture. And with the help of a HD camera, with the aid of an HD camera, we can get real-time pictures of distant locations, thus helping in remote surveillance also. And the fourth application is related to acoustic sensing system, and that is shipping traffic detection. From this application, we can come to know the number of ships that is moving at a particular location in water bodies, and thus helping in detection of the ambient noise in any marine environment or ecosystem. Now, moving on with the conclusion, real-time water quality detection is important for many industries as pure water is the most essential demand in the food and beverage industry, chemical industry, agriculture, fisheries, and for household supply. It would be beneficial for the concerning stakeholders to take precautionary actions before it's too late, thus helping the normal people of India. The future scope of this work is the modeling of a system that is an integration of both the models discussed here so that we can get real-time water quality parameters as well as the shipping traffic can also be detected for a complete water quality monitoring. So that was it from my side. Thank you so much.
Thank you so much, Chirag. Next, we have Athar from IIT Kharagpur presenting on machine learning based estimation of nutrient concentration for rivers. Athar.
Good morning, everyone. My name is Mohammad Athar Ansari. I am currently working as an intern at MRC, and also I am currently pursuing my MTech in System Science and Technology from IIT Kharagpur. So the topic of my project is machine learning based estimation of nutrient concentration in rivers. So these are the content on which I am going to speak. So let us understand the background of my topic. Rivers hold a variety of nutrients, including natural elements and those from external sources, which are very much important for the growth and development of plants, algae, and aquatic animals. The composition of nutrient in a river can vary depending on factors such as the river location, the way the land around it is used, and the activities of the people in that particular area. Some of the very common nutrients that can be found in rivers are nitrogen, phosphorus, calcium, iron, sulfur, etc. Basically, all these nutrients come from different sources such as runoff from the agricultural activities, sewage, or natural weathering of rocks. Excessive amounts of nutrients can have significant effect on ecosystem and water bodies. That is why maintaining a balance is important to avoid pollution and negative impact on water bodies. High riverine nutrient concentration can result eutrophication and degrade water quality. Let us see that why it is necessary to study nutrients in river. As we all know that nutrients play an important role in supporting the growth and development of organisms, but excessive amounts of nutrients will have some harmful effects like eutrophication. Eutrophication occurs when excess amount of nutrients like nitrogen and phosphorus causes excessive plant growth. This can lead to oxygen depletion and harmful condition for aquatic life due to imbalanced ecosystem. Oxygen depletion. When there is too much plant growth like algae in the water, it can lead to oxygen depletion. As these plants die and decompose, the use of the oxygen, similarly when organic matter breaks down like dead plants and animal waste, also consumes oxygen, contributing to the oxygen depletion in water. Third is water quality degradation. So water quality degradation occurs when there are too many nutrients in water, which makes the water unclear, dirty, and smelly, which leads to the water quality degradation. Fourth one is the impact on the human health. Nutrient pollution can harm humans through contaminated drinking water and seafood. So the two main objective of my project are, the first one is to study about the previous sampling method and their drawbacks. The next one is to develop a machine learning model for the estimation of nutrient concentration in rivers. There are two methods which are used for measurement of water quality parameters and they have certain drawbacks. Talking about conventional field sampling, basically it is a method where water samples are collected from various locations and then they are analyzed in a laboratory to measure the concentration of water quality parameters. It has some drawbacks like it can be costly and it requires specialized equipment and trained staff. It also takes time because sample needs to be collected, then transported to the lab and analyzed, which makes the sampling infrequent. This method may not fully capture the dynamics of the nutrient over time and across the different areas. It also can be difficult to cover large or remote areas effectively. Now talking about online water quality sensor. Online water quality sensor have solved the issue of infrequent sampling by providing continuous measurement of conventional indicators like pH, temperature, conductivity, etc. However, it is still difficult and expensive to regularly measure key nutrients using this sensor. Moreover, there are other possible issues like sensor failure, damage to the probe, and the difficulty of monitoring a wide area due to the limited number of available sensors. Now, by looking at this drawback, it indicates that there is a need of machine learning model in this domain. There is need of machine learning model in this domain because machine learning enables more frequent estimations of water quality indicators by analyzing data in real time, continuously monitoring the environment, rapidly generating the data and adapting to changing conditions. Unlike conventional field sampling and online sensor, which are often less frequent and may have delays in data analysis. Before moving forward, let us understand that what is machine learning in simple terms. Machine learning is like teaching computers to learn from example, just like we learn from examples in our daily lives. We show computers a lot of examples and let them figure out the patterns on their own. Then they can use what they have learned to make predictions or decisions on new things they haven't seen before. It's all about helping computers to learn and improve by themselves. There have been many applications of machine learning in this domain, such as water quality index models and the contamination detection models. The methodology of my projects involves the collection of the data, then data pre-processing and the feature engineering, then the selection of the model, then model training and testing, then evaluation of the model, then selecting the best pre-trained model. After that, transfer learning on the best pre-trained model for the Ganga River data. So I collected the data of the ATT watershed, which is located in China, and also I have collected the data of the Ganga River. The reason for collecting the data from ATT watershed is due to the shortage of the data for Indian rivers. Additionally, the number of records in the Ganga River data was insufficient to train a machine learning model directly. Therefore, I first trained the model using the ATT watershed and then transferred this pre-trained model to make prediction for the Ganga River data. So both the dataset includes variable like water temperature, which represent the thermal condition of the water, electrical conductivity, which represent the existence of the dissolved ions, pH indicates the acidity or alkalinity of the water, and the dissolved oxygen affects the nitrogen cycling process. And the output parameter in both the dataset is nitrogen concentration. So I tried three different models for my project, namely random forest, XGBoost, and artificial neural network. Among them, artificial neural network performed better than the random forest and XGBoost as it achieved an R2 score of 0.72. So R2 score ranges from 0 to 1, where a value closer to 1 indicates higher accuracy. Since the ANN model performs so well, so I choose it for transfer learning with the Ganga River data. In this transfer learning process, the ANN model achieved an impressive R2 score of 0.76, which indicate a strong fit of the model to the dataset. So I have attached a plot which shows the training error and the validation error. By observing the graph, we can see that the validation error is consistently lower than the training error in most of the iteration. This suggests that our model is not overfitting. In fact, the lower validation error suggests that the model performs well on unseen data, providing confidence in its generalization capabilities. This graph shows the plot of the actual nitrogen versus predicted nitrogen by the artificial neural network model. The left one is of the ATT watershed and the right one is of the Ganga River. Now from the plot we can see that the model has predicted values very close to the actual one. So talking about the application of this model, the model developed can be really useful for the environmental agencies and the water resource management authorities. They can use it to keep a constant watch on the nutrient levels in river. By continuously monitoring and predicting nutrient concentration, they can make informed decisions to safeguard our water resource and ensure healthy river ecosystem. The second one is when nutrients level in rivers are too high, it can cause harmful algal blooms and disrupt the natural balance of ecosystem. To address this, this machine learning model can be integrated into an early warning system. This system continuously monitors nutrient concentration and identifies abnormal levels. It then alerts the appropriate people or organization, allowing them to make timely action to prevent ecological imbalance and protect the health of the rivers. So the data set collected for this project, which is coupled with this developed machine learning model, this data set can serve as a valuable resource for scientific research and policy development. Talking about the future scope, the limited data available for Indian river is a big challenge. But if we can gather a lot of data specifically for Indian rivers, it will greatly improve the model's ability to work well for them. Having more data makes the model more general and useful understanding and predicting water quality in Indian rivers. To make the model better at predicting water quality, we can consider more factors like rainfall patterns, land use data, and how water flows. Including these additional variables helps the model to make more accurate prediction by capturing a broader range of information that influences water quality. By integrating sensor or remote sensing technologies, the model can access real-time data updates. This helps the model to give timely and accurate estimations of water quality. These fresh estimations are really useful for making quick decisions, which helps manage water quality more efficiently. These are the references. Thank you.
Thank you, Arthur, for your valuable presentation. I'd like to reiterate here that underwater domain awareness will be incomplete without water quality monitoring and the necessary technology that is required. We are at a stage where we need various technological interventions to make sure that our water bodies are protected, our water bodies are monitored properly. It is high time that we enter into the digital world. We take advantage of all the research going on. So I thank the 4 presentations we've had till now that focused on water quality monitoring and the various state-of-the-art technologies that have been going on. Thank you so much. And moving on, we have our next presentation by Meenakshi. She'll be presenting on urban flooding management. Meenakshi.
Yes, ma'am, sure. Let me share my screen. Yeah, so very good afternoon, everyone. Happy to be here with you. I'm Meenakshi Ganesh. I'm currently a postgraduate student in IIT Guwahati. I'm currently pursuing my master's in Earth System Science and Engineering at the Department of Civil Engineering in IIT Guwahati. So in MRC, I have run a project on water resource management for the riverine system of Brahmaputra. I've done a case study of urban flooding and the mitigation management using the hydrodynamic models. So these are the contents that I'll be presenting today. Introduction and what is the need for these hydrodynamic models and what are the methodology and what are the limitations and how we can overcome all those limitations by these models and what will be the future scope. So urban flooding in the Brahmaputra region of Assam, particularly in Guwahati, is a significant issue that has been affecting the area for many years. Now, what's in 2023, you might have heard in all the news is that urban flood issues has become, there has been a devastating floods in one part of Assam, resulting in a loss of life and properties and widespread destruction. So even before the monsoon began, continuous rainfall last week has caused the immense havoc and submerging vast areas of Assam, it destroyed crops and displacing hundreds of So the Brahmaputra, one of the largest rivers in the world, flows through Assam, and its basin is prone to heavy rainfall, urbanization, encroachment on floodplains, and also there is a inadequate of drainage infrastructure. So there is a very important need to understand these urban flood issues to overcome and to plan the proper mitigation measures. So why a flood modeling? How it will be helpful to monitor the floods? So there is an unprecedented urbanization and there are changes in land cover, like lesser percentage of pervious soil, and there is a degradation of soil and loss of vegetation that leads to siltation. And also there are infringements. It has narrowed cross section of drains. So collapsement of drain wells due to unscientific construction activities in the vicinities and dumping of construction and other wastes. So all these components, like we can add it together to do the exact flood modeling, which allows the detailed hydraulic analysis of river systems and channels. So the main research objective is to do the hydraulic analysis, which allows for detailed hydraulic analysis of river systems and channels. So it simulates how water flows through these channels during the flood events, considering factors such as channel geometry, roughness, and the boundary conditions. So this analysis provides critical information on the flood depth, velocities, and flow patterns, which are essential for accurate flood management modeling. So this research mainly focuses on the accuracy of the flood inundation map generated from this hydraulic modeling of Brahmaputra basin using the available global datasets. So what are the limitations on available models? So despite the significant advancements in flood modeling and mapping techniques, there are still several research gaps in the context of this Assam floods in the Brahmaputra river, and the utilization of Hector's flood modeling simulation and flood inundation mapping using Google Earth engine it will be overcoming those limitations. So it has specific application for flood modeling in the context of this Assam floods may have limited exploration, and identifying and addressing the unique challenges posed by these complex hydrological characteristics of Assam, such as like the Brahmaputra river dynamics and the intricate network of tributaries, it can contribute to filling the research gaps. And the integration of remote sensing data in HECRIS modeling it has very limited exploration, and it may require further investigation. So this particular project focuses on that, and this is the study area, Brahmaputra Basin. Here you can see the Guwahati region. So this is a topography and hydrology also broadly varies, and temperature also varies largely inside this basin. And as you can see, it has a very vast number of tributaries, and the river discharge of Brahmaputra is around 90,830 millimeters square, and there is a maximum peak discharge recorded at various stations in the Brahmaputra river basin. And why satellite-based monitoring is satellite-based monitoring of urban flooding is required, because it has wide coverage and timely and real-time data we can get, and there are a vast remote sensing capabilities like synthetic aperture radar and microwave sensors will be highly helpful to monitor the flood events. And we have the historical data and long-term monitoring, and we can integrate with GIS and other modeling system platforms. And also, like, there is an international coverage and collaborations in a global perspective. And these are the satellite and sensors which are available, and currently in this I have used Landsat 7 and 8 and digital elevation model of the SRTM dataset. This is the methodology in the data collection. So here you can see the Google Earth engine-based flood inundation mapping. It can be performed both before and after floods. So the approach and methods may differ depending on the specific objective and the data availability. So this is the Earth engine-based identification of flood extent and the flood-affected areas in the particular district of Assam. In this, you can see the like in the yellow color. So this time series analysis, it facilitates the analysis of time series data, and we can enable the monitoring of flood dynamics over time. So by comparing images from different periods, it is possible to identify the temporal patterns and assess the flood recurrence and track changes in flood extents and intensities. So these are the like research and discussion for that flood inundation mapping. So in this method, like for these images before the flood event, like we have considered 2022 1 May to 15 May 2022, and like we have found 2 images that match the criteria, and we have applied many image processing algorithms, and using the change reduction methods and the pixels backscattered values of the microwave remote sensing data, we could able to determine the changes that occurred and how much area has been inundated due to that particular period of floods. And then coming to hydrodynamic modeling. So this is the model framework. This is the data sets is required. These are the engineering problems that can be addressed. And these are the computational concepts, and the formal framework using mass conservation, momentum, and empirical equations are deployed into the Icarus model. And finally, we'll be doing the post-processing, and simulation will give the flood inundation areas by considering all the hydrological and all the hydrodynamic data sets. So these are the data requirements. Here I have given the data related to the hydrological information and like all the river channels, depths, and the channel width. Like this I have plotted the hydrograph. It shows the how flow rate changes over time at specific locations in the river. On the other hand, geometric information pertains to the physical characteristics of the river. So we have given the physical characteristics based on the available data, like digital elevation model, the Manning's roughness coefficient, and the normal depth at the downstream, and the river hydrographs at the upstream. So this information is essential to define the terrain on which the flow simulation will be performed. And while Manning's roughness coefficient helps to quantify the resistance to flow caused by vegetation, roughness elements, and other factors, as you know, like this Brahmaputra in Assam has a very complex geological and geomorphological features. So these are the results, and these are the digital elevation model which have been used, and we have given the boundary conditions upstream, downstream, on the lateral boundaries. And for this case, the upstream boundary was set to flow hydrograph, and as I mentioned, downstream was set to normal depth with the friction scope. And we have created a 3D computational mesh. So here, like around 70 to lakh 4,005 cells has been computed for the for the topographic data, and we have defined the cross sections. And the 2D mesh will automatically generate a computational grid that covers the entire study area for computational limits. We have considered one particular part where it will be mostly flooded based on the earth engine results, and we have adjusted the mesh density as needed to capture the necessary level of details. And then initial conditions and boundary conditions has been defined. So the unsteady flow calculations, these are the data sets has been provided, dates and the simulation time with the flow. So the time interval for the simulation as for the computational limitations, it is set at 1 day, and the output file was designed. And particular simulation period, time interval output file will be generated by steady flow calculations. For only we can use steady flow calculations, as it is a 2D modeling, it was under steady flow calculations. And these are the results. So here we'll be getting the manual after doing the manual calibration of Manning's coefficient, with the velocity, depth, and the geometrical simulations we'll be getting. Here the diffusive wave equation has been used, and it requires some fewer computational resources compared to more complex equations. So the efficiency allows for faster model computations, enabling the analysis of larger and extensive river systems. So here the diffusive wave equation is used. It is mostly commonly used to appropriate for steady and unsteady flows. And in steady flows, as we know, flow characteristics do not change significantly over time. And here, after the post-processing, we'll be getting the potentially flooded areas and affected cropland and the affected urban, we can differentiate and use on the some image processing algorithms. And if we have the population density, we can overlay on this, and we can come to know how much it has been inundated and how much it has been inundated so far within that particular simulation period. And it places significant emphasis on hydraulic analysis, considering the flow behavior and interaction between water and river channel. And this model incorporates all the hydraulic to model flow, flood inundation, as I mentioned, the boundary conditions, channel geometry, and the roughness. And it provides detailed insights into flood patterns and the hydraulic behavior. And then we have to validate with the available with already observed flood maps. So these observed maps are generated based on the actual historical flood events obtained through the satellite observations. So the simulated flood inundation maps has a very good match with the available observed flood maps that has been validated. And the future scope and challenges, these are the future scope that should be considered, like the climate change, urbanization, population growth, as that resilience of critical infrastructure systems like dams, drainage network is very essential for effective flood management. And these are the limitations and scope. The limitations should be considered in the future works, because existing drains should be mapped in detail using UAV or drone surveys, and we can get the existing drain details from the municipal corporation, and it has to be mapped very detailedly using the drone surveys. So these are the input layers we can give, and the conduit dimensions is very important. It should be obtained during the survey, and what are the impervious and pervious area, and the rate and the average slope should be derived from the subcatchments, and all these parameters should be incorporated into the available models for like effective flood modeling. Like all the other scenarios. So this all should be considered for the future works. We are proposing, by analyzing the scenarios, we can identify high-risk areas and determine the necessary capacities for stormwater drains to mitigate flood impacts. So a well-designed stormwater drain network will help to mitigate the impacts of urban flooding in the Guwahati. And as I mentioned, furthermore, it is essential to continually monitor and update the urban flood model as urbanization and climatic conditions evolve. So these are the way forward, and here you can see one of the NRSC map which was generated recently based on the synthetic aperture satellite data. Like you can see the 2023, the recent flood map on 6 p.m. at 15th, this month 15th has occurred. So to effectively monitor, we propose to collect the data of all the drains in Guwahati city, and we have to map all the drains, and we have to delineate the catchments, and then we have to incorporate all this to the comprehensive flood modeling. And these are some recommendations we're proposing: to identify the quick wins and sufficient assessment of proposed design and new alignment and some major construction segments. So it have limitations in adequately representing and analyzing local drainage systems. Like this HECRES model have some limitations, and like we have to integrate it with the proper drainage channels and the stormwater networks, and we have to consider all the local surface runoff patterns for effective flood management. These are the references that we have used. So climate change is not just about hot summers or rising sea levels. It's also about increasing in the unpredictability and intensity of extreme weather events such as floods. Thank you.
Thank you, Meenakshi, for your insightful presentation. I'd like to remind right now that our country is right now going through tremendous flood events. And as we can see, we are not well prepared. It's a deadly event happening, a lot of loss of property and life. So we need to work a lot on making sure that we are well prepared for the changing climate and all the other impacts that a country is going to face. Next, we have Arijit, who will be presenting his work on AUV design for deep sea mining.
So good morning, everyone. Myself, Arijit Bishar, a MRC intern, and also present pursuing MTech in Naval Architecture and Ocean Engineering from IIT Kharagpur. My topic is about AUV design and development for deep sea mining. So this is the contents of slide. First, I would like to start with the introduction, then why I choose polymetric nodules for mining, then the question I want to raise as a problem statement, then the answer I came up with my AUV design, and then the components of AUVs, the last and not the least, the further progress. So let me give you a brief introduction of an AUV. So basically, what is a AUV? AUV is an autonomous underwater vehicle that's self-propelled, unmanned or unmanned, and capable of carrying the simple activities. The next is a function of AUV. We can use the AUV such as a research purpose using sonar using the sonar and the other sensors, using for the exploration and the mining in the ocean, and also can use the military applications such as the intelligence and the surveillance. The next is why polymetric nodules. This is basically a manganese, nickel, and cobalt mixture that can be found in the ocean. There are so many things are there, but why we have to take particular this? Because of the availability. There are 4 locations where we can find it. As you can see in the map, there is CCZ area in the Pacific, Peru Basin, Pidhan Basin, and the Central Indian Ocean. 21.1 billion ton in the CCZ area in Pacific, 380 million ton in the Central Indian Ocean, and 20 billion ton in the Peru Basin. Total amount of these polymetric nodules in the world is basically 500 billion ton. So it can be the source of the energy. Estimated that 35 to 45% demand of the metal will come from the deep sea ocean. One estimation that is so interesting, we can build to 80 million of the 75 kilowatt electric vehicle battery from one CZ area. The next point is the economical impact. It's under the blue economy. It can be finish the demand of the metals in future. Environmental impact, it can be reduced by CO2 emission by 60%. Okay, so next slide is a problem statement. How can we extract these nodules? This is the main question. There are so many technologies being developed in this recent time. The nodules lying down in the seabed, you have to just take it. But the problem is there is enormous pressure here. So then I came up with my AOV design and development. I designed two AOVs for the different operation. One is the extraction, exploration, and the second is the mining process. Exploration can be done by the primary UV and the mining can be done by the secondary UV. Primary UV, it has torpedo design and have so many sensor and sonar to know about the topography of the seabed and find out where the polymetric nodules are stored. The secondary UV, it is basically basically under the non-torpedo design. It has buoyancy engine to move the vertical direction and have store facility for the nodules, and it has also robotic arm. Okay, so this is my whole the picture. As you can see in this picture, this is the primary UV with the secondary UV attached to the special locking technology. After knowing where the nodules is lying down, the secondary AUV arrives in this picture. Then the secondary AUV going down to the deep depth and take it so smoothly with the robotic hand and stored. The secondary AUV can connect with the primary UV for two purposes. One is traveling for two for the research purposes. Okay, so I have used SolidWorks software to design the primary UV and also the propeller. AUV is under the torpedo design because of very low drag condition. And the propeller design also completed by SolidWorks. This is under the German propeller Boss Vortex diffuser. I have selected this type of the propeller for two reasons. One, it reduces the acoustic signature as well as it can increase the efficiency also. This is the secondary UV. This design is also completed by SolidWorks. This design is for the vertical motion. The next is the robotic arm that can take the nodules as much as possible. Okay, so this is the results. This ANSI simulation results. This is for the primary UV. As you can see in this picture, how water is passing through. This test is conducted in this very small enclosure. Okay, this is the ANSI simulation of the propeller with the help of the ANSI friend. This is basically the water velocity and the pressure model. As you can see in this GIF, how the pressure can be changed with the location. So next slide is the ultimate aim of this project. If I talk about the Central Indian Ocean, National Institute of Ocean Technology, Chennai developed its own technology where ROV work as a crawler, take the nodules and the crushed it with the water and make some slurry. That slurry sent to the mothership with the pump via long haul. So this technology can destroy the deep sea environment, and also this slurry could be the poisonous to us. So my design is basically the environment friendly. It can minimize the destruction of the deep sea biological habitat and it also the time efficient. Next is the further progress. Just 1 month is not enough to design the whole thing, the whole project. So so much thing have to complete, like estimation of the payload, the electrical and the computer architecture of this project, and the visualization of the work path and with the AOV, the help of the path detection algorithm. So we have to take this is for long. And I would like to conclude my presentation with some quote. There are two facts in two things: science and opinion. The former backs the knowledge, the latter is ignorance. Thank you.
Thank you so much, Arijit. That was a really that was a great presentation. A lot to learn. And since our country is gearing up to secure our water resources, ocean resources, it'll be a great contribution from MRC's end. And next we have Pratham, who will be presenting on AUV design for climate change. Pratham.
So hello everyone, my name is Pratham Chandurkar. I'm a research intern at MRC Pune. I'm currently pursuing MTech in Thermal and Fluid Sciences at IIT Kharagpur. The project name is Design and Development of AUV for Climate Change Monitoring, where AUV stands for Autonomous Underwater Vehicle. This is my content slide, which includes the introduction, objective, methodology, followed by modeling and simulation. Then we will discuss the result and conclusion of this project, followed by the further developments. So let us go to the introduction part. So about the climate change. In 1824, the French mathematician and physicist Joseph Fourier proposed the greenhouse effect theory, suggesting that the gases in the atmosphere trap heat and regulate the Earth's temperature. After this, various studies are done to understand the impact of greenhouse gases on climate. And after this only, climate change attracted the global attention. Causes of climate change are deforestation, industrialization, burning of fossil fuels, etc. While climate change has adverse impact on such as rising temperatures, changes in weather patterns, biodiversity loss, changes in precipitation patterns, health impacts, etc. But it is not only limited to the terrestrial ecosystem. In recent years, climate change is causing some serious changes in oceans, including temperature increase, sea level rise, acidification. Oceans are becoming more acidic as they absorb more carbon dioxide from the atmosphere, and concurrently oxygen levels are decreasing, and which is harm to the underwater ecosystem. Hence, various devices are used for this climate change monitoring to understand the changes, such as AUVs, which is autonomous underwater vehicle, ROVs, which is remotely operated vehicle, ocean gliders, bios, mood instruments. We are using AUV because it is more cost effective and less time consuming as compared to the other devices. UV has various uses such as oceanography research, underwater mapping and surveying. It can also use in oil and gas industry, environmental monitoring, and underwater infrastructure inspection, and also for coral reef monitoring, which is the aim of our project. So let us understand the coral bleaching. The coral bleaching is the process in which the coral lose their vibrant colors and turn pale or white. It happens due to the increased ocean temperature. It is a severe issue because once these coral die, these never come back. Corals are very important for coastal protection. These also acts as a carbon sink, and hence there is a need for coral reef monitoring. Now we can use the AUV for coral reef monitoring for high resolution imaging, water quality analysis, and coral mapping. So AUV design and development for climate change monitoring is a very broader domain. It has various aspects such as mechanical aspect, software aspect, electrical aspect. The mechanical aspect can include the structural integrity, thermal management, and stability of AUV. Mechanical means we have to check whether an AUV once deployed underwater will be dynamically stable or not. So that is the objective of our current project, to evaluate the dynamic stability of AUV with the help of CFD, where CFD stands for Computational Fluid Dynamics, which is a sub-branch of mechanical engineering. In this project, we will simulate the captive model test for AUV in ICCFX, which is commercial code for CFD, and compare the results with the experimental data. We'll then declare the stability of AUV with the help of stability criteria for AUV or submarine. So this is the methodology of our project, in which we'll first build a model of an AUV in the SolidWorks. Then we'll measure the model for accurate results. Meshing is very important in the CFD. Next part is the simulation of steady state drift test and rotating arm test in CFX. After that, the results often from this test, such as hydrodynamic coefficients, will be compared with the experimental data of the DARPA model for the validation part. After this, we'll evaluate the dynamic stability with the help of root stability criteria with no control input, and with the help of results obtained from this previous simulation. The first part is a model. We choose the model of the Maya IOV because it is used for coral bleaching. The reason why we are using this AOV is because it is good for tracing the seabed terrain. It is very small in size and it weighs around 55 kgs, which is the least among all the AOVs. About Maya AOV, it is developed by the National Institute of Oceanography, Goa. As we can see from the picture, it is torpedo shaped with two radar planes, which is used for yaw movement, and two stern planes for the to control the pitching moments. It also has the thruster and at the end and lithium polymer cells, which are used for the energy purposes. So this is the model which I have modeled in the SolidWorks with the given dimensions, which include the front view, side view. Next thing is the control planes. The control planes, which are rudder planes and stern planes, it plays very crucial role for the design of AOV because it controls the pitching movements and yaw movements. We use the NACA 0015 profile for this control plane. It is used because it is very good in terms of the lift to drag ratio, and it is widely used in the application of submarine and AOVs. The next thing we do in the CFD is the meshing. Meshing lies at the crux of the CFD. The definition of meshing is the discretization of the domain for solving the equation. In simple terms, we can say that meshing is the process of dividing a geometric domain into smaller elements or cells. Then we solve the equation for the smaller domain, and we'll get the output, get the aggregated output as a pressure output or velocity at the wherever we want. There are various metrics which are used to check the validity of the mesh, like skewness, aspect ratio, or orthogonal quality. We have considered the orthogonal quality here. The minimum permissible orthogonal quality is 0.1, and our orthogonal quality is 0.2, so which is allowable. The next thing is boundary condition. We use the velocity 6.5 knots per second because it also coincides with the experimental data available. We have used the conventional boundary conditions such as pressure outlets and walls. Pressure outlet is a Gauss pressure, and the walls are equipped with the no slip conditions. The simulation part includes the captive model test, which includes two different tests, two steady tests such as drift test and rotating arm test. Drift test will calculate the rate coefficients of sway force and yaw movement with respect to the velocity, while rotating arm test will calculate corresponding to radius. So we have taken 18 different drift angles for our simulation, ranging from 0 to 18, and we have input the velocity, so the surge velocity, sway velocity, corresponding to this every angle. These are the simulation of drift tests we have done in the ANSYS CFX, ranging from 0 to 16 or 18 degree, and we can this is the velocity contours that are plotted. We have used the experimental data from the DARPA SUBOP model, where DARPA stands for Defense Advanced Research Projects Agency. This, as we know, that countries which build the submarine does not share the data because it is confidential. Hence, this DARPA, this agency, is providing us with the experimental data for comparing with the CFD simulation. This agency focuses on the simulating and analyzing the complex interactions between submarines and their operational environments. These are the result and conclusion which are obtained from our current progress. It is evident from the graph that with increasing drift angles, sway force will increase at each side of AOV will become asymmetric, and there will be some pressure differences across both the parts. This also affects the lift and drag forces, which is important for the stability of the vehicle. There is not major increase in the sway force above 15 degrees, and this is also observed from the literature part. There is significant abrupt variation in the surge force with the surge velocity as with every angle because there is a change in the frontal area available. So this was the current progress of our project, where then after this we will focus on the expected developments. which will first include the verification with the experimental data obtained from the DARPA model. Then we will simulate the rotating arm test. The results obtained from this rotating arm test will be hydrodynamic derivatives of forces and moments. We'll use these results in the root stability criteria, which is function of these derivatives, and we will conclude the stability of the AOV, whether it is stable horizontally or vertically or not. These are the references I used for my project. And I conclude my presentation. Thank you, everyone.
Thank you, Pratham, so much for your presentation. I'll now request our director, Dr. Arnab Das, to give his comments on the presentation for webinar day 3.
Thank you, Catherine. I think it's a continuous thing last 3 days, and I would also like to compliment first the interns and also the team led by Sridhar, Catherine, Shreya, Ananya. All of them have put in a lot of work to bring it to a level, and as you can see, there has been, I mean, the spectrum of projects have also expanded, have become broader, but at the same time, the depth has also increased. As I had mentioned on the day one, there is a lot of backend infrastructure that we have built up now to make sure that we are able to provide the backend support in terms of data analytics and also in terms of the material that is required. So I think I'll not take too much time, and I'll request Ambassador Mudgal sir to kindly give his comments.
Thank you, Arnab. Sorry I missed the program yesterday. Hopefully, today I will be able to kind of balance that loss for myself. Again, Arnab, very interesting presentations. Sometimes we look at these presentations in isolation, standalone kind of a thing. And for an ordinary person, sometimes the standalone presentation probably will be difficult to digest how it will solve their problem. But let me tell everyone who made these presentations, these are the building blocks for larger solutions. On their own, they may look very, very focused on a particular issue or a particular niche or a particular domain. But when you build these, when you integrate these building blocks into larger solutions, I would want to tell the participants, you are working on solving very large issues which are facing the humanity. Many of them mentioned about global warming, many of them mentioned about seabed mining, many of them mentioned about the water quality. Now, all these issues in their own right may appear, okay, it's a sectoral issue and may find some application somewhere. But when I look at these things as somebody dealing with larger issue of blue economy and oceans and sustainability, I find so much of hope in this, that because if I go back by 10, 15 years, the young scholars were not working on these issues. But today they are in fact graduating into the futuristic issues which the humanity is going to face. In fact, today I got an email from my collaborators about, I mention all the time the Earth's Overshoot Day. Now we are looking at the Earth's Overshoot Day on 2nd of August this year, which means on 2nd of August this year, we are going to exhaust our quota of Earth's resources. Beyond this, we shall be digging into the Earth's capacity for future, which means we will be eating into the future generations' capacity to utilize or harness these resources. Now that brings a lot of responsibility on us. How can we make sure? Because you look at the data, Anam, I was surprised that till 71, the Earth's overshoot day was falling in December. And just in what? About 40 years? Where are we? The Earth's overshoot day is falling in August. So I want to tell these youngsters that you are trying to resolve this challenge. Shall we keep over exploiting the available resources? Or we shall be able to reverse the whole process, and very soon we'll again have a situation where the overshoot day will fall in December. Or why in December? Maybe next year, January, February. Let's repay the planet's debt. And how shall we do it? There are 3 or 4 broad pathways to this. One is, I repeat that in all my conversations. One is the Gandhian way, which means, can we reduce our consumption to fit into the capacity of the planet? I think this is probably one of the best things to do. But my worry is that we have walked so far that going back into that philosophy looks almost impossible. And if there is a possibility of that philosophy, that will also come through education and providing knowledge to the people that we can take you back to those lower consumption levels without affecting the standard of your life. We can do it because our consumption is not only excessive, but is also extremely inefficient. So can we make this consumption more efficient? Which means, can our consumption be less resource intensive? It can be. There are hundreds of examples I can give you. So the technology will make your consumption less resource intensive, but it will not solve the problem entirely. The other could be the circular economy. Can we go back to recycling those resources and make sure the waste is not a waste? Waste becomes a resource and we bring it back. And the third possibility is, can we find new resources and apply the sustainability standards for harnessing those resources? And that is where I link this whole conversation to the underwater domain awareness. Having exploited the land-based resources, now we are heading towards the ocean for expanding that source of resources. By all means, please do it, because we have been doing it for generations. But this is where we have to be very careful. In fact, there was a presentation on the seabed mining. Last week somebody sent me a research paper. The Japanese had carried out a very minor experiment on seabed scratching, as we call it. Not mining. Just to do some kind of scratching and see what impact it has. Today we have results that a very minor experiment with the seabed mining led to a massive loss of biodiversity in the region. And not only in the region of experiment, but far, far away from that region, which means we are looking at what kind of risk we are looking at. Now, that is where, in fact, the underwater domain awareness will play a major role in understanding the impact of the new technologies we are talking about. Now, we are all aware of the biodiversity treaty, in fact, beyond national jurisdictions. And one of the core requirements there is the environment impact assessment of whatever we plan to do with the oceans. How would you do environment impact assessment without full command over the underwater domain awareness? Right? And A, it is knowledge intensive. B, it is technology intensive. C, it is patience intensive. It needs a lot of patience, in fact. It is diversity intensive. It's a dynamic process. Yes. And therefore, in fact, what you people are doing, what these youngsters are doing, is going to be a great service, A, for enabling us to harness those resources, B, to caution us if our approach is wrong. So this will be an advance warning. They'll be able to give us advance warning where they will say, please don't do this with this technology because it can hurt the environment. We are overusing the Earth's resources today by about 56%. Can you imagine 56% overutilization of the planet's capacity? And this is unsustainable, in fact. And therefore, I would request the candidates, when you do a niche specific project of research, just keep in mind, how would your work relate to a larger solution? Because at the end of the day, we need solutions. And integrating knowledge into solution is important. And that is where, in fact, developing countries or emerging economies like India, we lose out. We have a tremendously solid base of knowledge, but somehow we are not able to convert that knowledge into solutions. And that is why then we look up to the others to provide the solutions. They use our knowledge to create the solution. Can we at least keep that in mind? That at the end of the day, knowledge without a solution has limited application. The knowledge needs to be converted into a practical solution, right? So I am very happy that at least now a large number of very bright minds have started working on this very complicated, complex issue, and I'm very hopeful that they will provide solutions to these challenges very soon. And that day, in fact, I will stop worrying about the overshoot day. Yes. And I will say, all right, now we don't overshoot. Yes. So with these words, I congratulate everyone. I congratulate you, your team, for doing this excellent work. Very few people are doing it. And that is where, in fact, the hope lies. Thank you so much.
Thank you so much, sir. Just wanted to let you know, yesterday's presentations covered climate change. Sir. There were 4 plus presentations on climate change, different aspects of climate change, and also shrimp and seaweed farming. I mean, the APY tool that we have developed. And so, as you rightly said, sir, our aim is also to inject different ideas or different dimensions of the underwater with these young, bright minds. Would also like to inform the audience that one of our research fellows has just shifted to US 2 days back for her PhD, and she has been very kind to acknowledge that she has been with us. She's from IIT Delhi, and she has been with us for more than a year. She joined as a young intern, but then she came back to say that, sir, I would like to continue working with you. And she worked on sediment transport prediction. So, I mean, what I want to also emphasize that these bright minds will be in very high level decision making in future, and they being conscious of Ambassador sir, what you said is, I think, a very good news for all of us. With that, I will request Admiral Verma sir to kindly give his comments.
Very small 30-second addition.
Sir, please, sir. Please, sir. Please, sir.
Again, in fact, I got a paper today about combining mangroves with shrimp cultivation. Now, I'm sure you're aware of this. You see, one important cause for mangrove loss is the coastal zone aquaculture for shrimps. Now, I told you earlier, there was, in fact, a project for combining shrimp with paddy culture. Paddy grow. Paddy, because there's a paddy grows in waterlogged conditions. So that can give you maybe 1 or 2 cycles of shrimps, right? But with mangroves, in fact. Now, how mangroves and shrimps can help each other in growth and protection of the environment. So I think, we need to work on these things on the ground to demonstrate to the people engaged in fisheries that this is a better way rather than cutting off the mangrove to create aquaculture spaces. Use the same space with mangrove, in fact. So mangrove will provide some inputs for shrimp, and the shrimp will provide some inputs for mangrove, and both can flourish, in fact. And mangroves are a very major source for carbon capture, in fact. Very few people know that a small percentage of the phytoplanktons which die and settle at the seabed, sequestering carbon dioxide, their contribution to carbon sequestering is more than the entire land-based, organic system, which is all the forest and the agriculture and everything. The amount of carbon they sequester is less than a small percentage of the phytoplanktons dying and settling at the bottom of the sea do. So I think these are wonderful, sets of information, but we need to build them into larger solutions.
Sir, in fact, just to half a minute, I'll also take to. Shlok has been progressing our work on shrimps and seaweed, and there's a concept of poly cultivation or poly farming where seaweed and shrimp can also be combined, and basically it's a nutrient balance that can be achieved. And with the digital tools or the prediction tools that we have been working on, these are the modeling and simulation effort that we have done. Instead of actually burning your finger with fire, I mean, you can actually use the digital tool, and which will be far more cost effective, and which will be far more better, because when communities are involved, their livelihoods are involved, they work with very small budgets. So in fact, we are also now in talk with a livelihood expert, because all these tools, as you rightly said, it has to translate to solutions. Just the knowledge cannot help. So, and I mean, it's been a phenomenal learning for me as well, sir, to be very honest. All these youngsters come out with different ideas, and I myself learn quite a bit. And even what we have seen is the multidisciplinary requirements that exist in terms of coming up with a much more realistic solution. So slowly and steadily, we are definitely getting hold of all the kind of expertise that are required. And I mean, of course, it will remain work in progress, but the tools that we are working on can really give you a good idea at the policy level and also at the technology intervention level. But before we actually invest and go into the ground. So that's how we've been working. And with each work, we continuously improve the precision and the accuracy of our models. And now, as I said, on the first day, we are going into field deployment of sensors. And you can see these sensors are multi multi-sensor suits that we are talking about. So these inputs will be extremely important across various applications. It's not limited to just one. So, and you can see the diversity of work. And once these sensors get deployed, then you can imagine the kind of data that we will have. And so today in India, that has become the biggest challenge of I mean, data not being available, and we are trying to work around through various ways. So I think we'll continue this discussion, sir, and I'll request Admiral Verma, sir, to kindly give his comments.
I think after what Ambassador Mudgal said, if I have to say anything, it'll be really stupid. So I totally endorse whatever Ambassador has said. He's covered it in a big thing. All that I can say is I have learned a lot in this session. In this session, I've learned a lot. A. B. I also have observed that, we have so little knowledge of what to do with water here. And this is very, amongst all your, sessions, I believe this is a very important session because water management, is absolutely, people have to understand what is water management. I'm not sure the powers that be have understood that. Now, these tools that you're, suggesting, with these tools, if you can prove something to these people on thing, then Ambassador and all can sort of push it forward. Because what I have noticed from my experience is that even in my own field, nobody believes you when you talk thing, but when you show, something happens. So you are on, I mean, the tools that have been mentioned, what they want to do, how they want to do, use satellite, why satellite, why not this, etc. Fantastic. I mean, it's you put everything now on a paper or but through a research paper. Now we should, if you, of course, I agree with you, this is all work in progress, but let's not wait for the end. Let's start educating those, powers be that this what's happening, this sort of thing. Can I do some little test for you? Can thing, and as you're saying, the field trial is okay. Field trial is again satisfying yourself. But my problem is, this thing is this education that you're giving me is good, but it also has to be to the powers that be in a regular little manner because they cannot consume a lot. So don't wait for the finish. Start now. One very interesting aspect which was brought out as for the design and development of the deep sea mining. Now, I am I totally agree with him because I've seen the presentations of NIoT, etc., their AIV thing, their trawler, for thing, the slurry extraction. And some of the things I did mention is that, okay, fine, we've gone there, we've found the nodules, we have done a little, we know how to carry it back, etc. But what about the damage that we're going to cause? So that has to be studied so that your tools become better. So I'm very happy. I thought this idea of having a AUV and a secondary AUV that will just go and do what thing is a pretty good idea. So since NIoT is there and you're very this thing with the earths and sciences, because obviously you can give them ideas with the concept, with the thing, etc. But actually doing the work, I think if you tie up with these people, it will help in pushing this in the initial stages. Arnab, you and I know how the government reacts or how our own laboratories react. So we know we should, we have no choice. We have to use them and get them. So I think I have not seen this idea of going there and something goes and comes back. Yeah, there will be still some slurry which will come, but it will be contained in that area instead of carrying the slurry further, right? Still, the damage that happens to that, how is that being looked at? That also is a thing which probably next group of people can look at it. And yeah, designing an underwater AUV for the heck of designing is no use, because everybody is designing a thing they've made and it's floating, but they don't know why it's floating and why they have made it in the first place. So I'm glad that you're taking deep sea mining, you're taking for climate change. That's the way to go. As I said, I learned a lot in this thing, and of course, for the last 3 days we've been seeing how to create tools, and now even here I noticed that we have tools. We have created tools or concepts of tools, because we think now we need to go a little forward in your next team. And I'm sure you have a program, because you're always thinking ahead of the crowd. And I must also congratulate all your fellows who are monitoring and helping these people, because this is something, and I'm sure Ambassador will agree, that we've done enough damage. So let's start looking at how to pay back for our sins, and that's important. Thank you very much. And though I told you I may not be here today, but I was tempted after looking at that, and I've kept chaps waiting. But I said I must spend. I thought I'd spend 5 minutes, 10 minutes, 15 minutes, but I can assure you I sat through all of them. Okay, thank you very much. Thank you, Ambassador, for your guidance and for these young minds in the right direction. And I think this is the most important part of the underwater domain. I'm not interested in submarine. I'm thinking about this is the most important. Your life. If you don't have life, and if you don't think, what are you going to do with a submarine?
Absolutely.
So, yeah. Okay. Thank you.
So much, sir. In fact, I mean, in the next few stages, it will be multiple projects coming together for a larger solution. So we are definitely working towards that. And along with interns, we have fellows who are going to stitch them together. Tomorrow, we have 3 presentations by our fellows who not only do their own research, but also look at how to put things together. I'll request Commodore Dr. Sumin Banerjee, sir, also to kindly give his comments, sir.
Thank you for this opportunity, but I have no comments after hearing Ambassador and Vice Admiral. I'll just reserve my comments for today. Thank you so much.
Thank you so much, sir. Thank you once again, everybody. And I think, Mudgal sir, all the presentations are available in recording. We'll be sharing them with you. And I would also request you to have a look at the presentations yesterday, sir, because you have been a proponent of climate change and various aspects. And even the work that we are doing together under your guidance, I think those presentations will be extremely relevant. And we have been trying to reach out to various authorities in the government, and at least now people are listening to us, sir. I mean, it has to yet to convert into major action, but Admiral sir, I can assure you that at least people are listening to us, and I would like to thank Mudgal sir also for multiple connects through him. But I think I'm very optimistic as I speak today, because in I think next 2-3 months the blue economy policy will be announced by the government of India. So there would be a natural awareness about water and the various aspects of the blue economy. And our effort is to be ready when such major announcements are done and major initiatives are taken by the government. And we hope to get an opportunity to contribute in a larger way. But as I repeatedly said, sir, our backend team also, now we have 4 to 5 engineers working in our backend team. And that team is also becoming bigger and bigger to make sure that the backend infrastructure is ready to support the researchers to kind of continuously do things. And the data collection has also begun, so that will be an important area, sir. So thank you very much for joining us today, sir.
Thank you. Thank you so much.
Thank you, Catherine. Thank you, Mehul. I must not forget Mehul.
Thank you, sir.
Thank you so much. I'd like to thank all the interns for joining in today. We had a very fruitful day 3. I thank all the dignitaries and the guests. Thank you for your valuable comments and giving us a futuristic idea of what we are doing, where we are headed. Thank you, sir. Thank you, Anup sir. Thank you, Anup sir. Thank you, Vice Admiral Arma, and thank you, Soman Banerjee. Thank you so much.
Thank you. Thank you.
Thanks.